Hi, my name is Philip from Harbin Institute of Technology in China. Today I will present you our paper called Mining Locally Trending High Utility Item Set. So it is a paper about pattern mining, finding patterns in the data. So in this talk, the plan will be like this. I will give you some introduction about high utility item set mining. I will define the problem that we study in this paper. I will show you our new algorithm and then show you some experiment and then conclude this presentation. Okay, so first I want to introduce a popular problem now called high utility item set mining. The idea is we want to analyze the customer behavior when they go shopping, like they buy some products at the supermarket. So the input is like this. We have a transaction database with many transactions made by some customer. So for example, the first transaction, some people buy 2 bread, 2 cake, 1 eggs, and so on. So A, B, C, D, E is the items, the products. And we have a unit profit table, like apple is $5, bread $2, and so on. So the goal in high utility item set mining is, given some minimum utility threshold, some minimum amount of money, we want to find all the sets of items that make at least this amount of money in the database. So this is some enumeration problem. There's one exact solution. So for the database we have on top, if we set the minimum utility, the minimum amount of money to $40, we want to find all the HUI, the high utility item set, and this is the correct answer. So bread, for example, make a total utility or profit of $92, bread and egg $44, and so on. Okay, so this is a popular problem, but one limitation, it does not consider the time. So Hackman and al., they propose another problem, a variation called trending high utility item set. The goal is to find the sets of items that yield a high profit and they follow some increasing or decreasing trend over time. So some products become more and more popular or less and less popular. So to do this, they have a database like this with timestamp, and they calculate the slope in terms of profit to see the utility is increasing or decreasing for the item sets. So there are some limitations about this work, is that they only focuses on discovering item sets that have trends for the whole database. So that means some set of items always increase or always decrease, but not only during some specific time period. So this is, we think, not so realistic because the trend must be stable over the whole database. So in this paper, our goal is to remove this assumption. We want to find some trends, like some products purchased together make more money, it increase or decrease, but not for the whole database, only for some non-predefined time periods. So we call this the locally trending high utility item set, LTHUI. So for example, maybe school bag, pen, notebook is a set of items that has some upward trend during the back-to-school shopping season, but not during the whole year. Okay. So how to do this? We use a database that first we divide the database into some bins according to the time. So a bin of, let's say, 3 days or 1 week and so on. So we divide the database. We have from the past to the future, okay, it goes like this. And then we divide into bins. The first bin from time 1 to time 3. The second bin from 4 to 6 and so on. So we have what we call a bin database. Then what we do, we will use some window over the bin. So a window, for example, has a size of 2 bins. We'll use a sliding window. So we divide the database, the time, into bin, and then we will slide a window over the database, and we will try to find the item set that have some upward trend or decreasing trend in some windows. This is the main idea. So here in the PPT we have some more formal definition, but I just want to give you the main idea. So now, to see if the trend increase or decrease, we will calculate the slope. So here we have a lot of details, but the idea is we calculate the slope for some item set X for a window. So we want to make sure in this window the item set has a trend that increase or decrease. This is the main idea here. So the problem definition in this paper now, an item set X is a locally trending high utility item set if there exists a window from bin I to j such that the length of the window is some specified length, and the utility of X in that window is at least some minimum, and the slope must be greater than some minimum slope. To find the upward trend, we could do the same to find the downward trend also. It will work. So here in this example, we could find that BC is a locally trending high utility item set. If we set the bin length to 3, the window to 6, the minimum utility to 20, and the minimum slope to 0.15, because BC at the beginning has some upward trend. It makes more money over time. Okay, so if we find such pattern, we believe it is interesting for the user, like the manager of a store, to find that there's some trend now. At some points in time, like before Christmas or Halloween, the products start to make more money. It keeps increasing or decreasing for some reasons. So here we have the details of the calculation. I will skip the details. And also for the windows. Okay. So, and we have the details of how to calculate the slope. Okay, so for an item set X, a window where the item set will have some upward or downward trend, we'll call this a trending high utility period according to the parameter. So here, BC has some upward trend between bin 1 to 3 in our database. Okay. So here again we have some detailed calculation. I will skip the details because we don't have so much time. So our problem is to find a new problem is locally trending high utility item set mining. We want to find all the locally trending high utility item sets and their trending high utility periods. So the windows where their utility is upward or downward. So for example, for the database I just showed you before, if we set the parameters like this, we find 3 locally trending high utility item set, and we find the window from time 1 to 9, for example. These item set have they are locally trending. Okay. So in this paper now, to find the solution, we designed some algorithm called LTHUI-Miner. So I will not explain all the details, but it is similar to LTHUI-Miner, a famous algorithm for high utility item set mining. So the idea, we start from the empty set and we do a depth first search. So we look, for example, at A, like apple, apple and bread, apple, bread and cake, and so on. Okay, so we explore the search space here using a depth first search, and then for each item set we calculate the utility, the money. We calculate also we look at the different windows to find the windows where this item set has a high utility and it has a slope such that it is also trending, and we want to find these periods. So as in LTHUI-Miner, we use a vertical structure for each item set, and in this structure we keep all the transactions where it appears, the utility, and we keep information about the windows also, and we calculate the utility for the bins and the remaining utility like in LTHUI-Miner. Okay, so I will skip the details. So, and then when we have some item set like B and C, we can combine the two structure for B and C to get the structure for BC. So we don't need to always read the database. So again, I will skip a little bit the details about the algorithm. Okay. So we have also some optimization, because in such pattern mining problem, we don't want to look at all the possibilities. We don't want to look at all the windows. So we have three search space pruning property. So we can prune some items if for all the windows the utility, some upper bound of the utility is smaller than the minimum utility. We have another about for the database using what we call another upper bound, the remaining utility like in LTHUI-Miner. And also using the window, we can also eliminate some item sets, some windows from the search space. So again, I skip the technical details. If you are interested, you are welcome to talk with me. I can explain more also. So we did some experiment. For this, we used two shopping database, Retail and Food Mart. Food Mart has some real utility value. Both of them have a few thousand transactions, many items, and we look at the execution time of our algorithm with and without optimization, and we change the parameter like the minimum utility, the minimum slope, to see the influence on the runtime and the number of patterns. So in terms of runtime, here we have in blue we have our algorithm, and then without the pruning property tree. So we see it is faster when we change the minimum utility. The time will increase when we decrease the minimum utility. This is expected. And when we use our optimization, it will be faster, like here for example also. So this is something we expected. Our optimization improved the speed of the algorithm. So we also find some patterns that had a very strong trend in the data, in the real shopping data. So some items had a positive slope in Food Mart and retail. So in conclusion, I don't want to talk too much. We don't have so much time. We define a new type of pattern named the locally trending high utility item set. We presented some new algorithm with 3 optimization. And optimization are useful to reduce the runtime, and some patterns having some strong trend were found. If you want the source code and data, you can download from our website. That's all. Thank you.